Hi guys, in this video I'm going to be walking you guys through step by step how to take an ACU or Autodesk Certified User Exam on Gmetrics. Gmetrics is the practice software that we use before we take our certification exam, and it is very similar to the actual real certification software that we would use here in my class. So throughout this video, I'm going to be showing you guys where to locate each of the individual pieces of information, where to click, and what you should be looking for. If you need to take notes, please feel free to take notes, rewind the video when necessary, and pause when you need to. If you have any questions, please make sure that you ask me throughout the process and that you guys understand what is going on. So let's get started. So when you guys are starting, you should already have Inventor opened up on your screen. And this is what you guys will see. It's just the regular basic setup. Some of you guys will have files here. I have gotten rid of all my files. I just want it to be clean, so I'm not looking at anything more than what I need to see. On Schoology, I have put a link for you guys that says Test 1 Gmetrics files. If you click on this link, here is all of the different files that you guys need to use during the Gmetrics tests. So if you click right here up at the very top where it says toggle selection for all items, if you click all that, it'll select all of them. And you can click on download and it'll download all of these items to your computer, and it makes this a lot easier process for you guys when you are taking this test. Okay, so let's go ahead and look at what we are doing. So what I have done is I have taken each question from Gmetrics and I broke it down into its individual objectives. And we're going to go through each section so that way you guys understand what you are looking for. So the ACU exam, or the Autodesk Certified User Exam, consists of 30 questions covering 6 different objectives. You will have 50 minutes to answer all 30 questions. That breaks down to 1 minute and 39 seconds per question. Some questions won't require that much time, and some questions do require a lot more time. So please make sure that while you are taking this test that you are using your time wisely. So, like I said, we're breaking things down into the individual objectives. The first objective is user interface and navigation. How to change the viewpoint using the view cube, change the settings of the view cube, and understanding Inventor file types and standard templates. For the second objective, assembly modeling, it's basically how to create assemblies, how to constrain them, where to ground things, how to apply offsets, determine the degrees of freedom, and create a presentation model. Objective 3 is drawing, how we lay things out on a sheet, how we can change the scale, change the sheet size, etc. Part 4, part modeling, is applying fillets and chamfers, creating ribs, creating extrusions, holes, patterns, and different things like that. Objective 5 is sketching, so how we create things, assigning parameters and dimensions, creating sketches, and using constraints. And then the last thing that we'll be covering, the last objective, is browser editing, the reordering of features and how to delete features through the browser. So what I have done is I've broken down the test from its random order into individual objectives. So objective 1 is the user interface and navigation. Now this is where we'll go ahead and get started on the actual exam. So all of those files that I had you guys download, you should find them in your downloads folder or wherever you chose to download them. And the first question asks us to open view management. So I'm going to go to my files and I'm going to click on View Management. So View Management opens and this is what we see. And now we just have to go ahead and read the question. The question reads, or it says, change the ground plane settings. Add 10 millimeters to the minor grid display. What is the new setting? Now, normally I don't really teach you how to change these things because there's no reason for it, but you know, the certified or the certification exam wants to make sure that you know this. So to change the ground plane settings, we're going to go up here to View, click here, and then we see that we have these different panels. We're going to go to the Appearance panel and we're going to find Ground Plane. When you click on Ground Plane, you're going to click on the pull-down menu and go to Settings. It's asking us to change the grid display. So we find Grid Display. We have Position and Size, Appearance, Grid Display. Here we are, and it wants us to add 10 millimeters to the minor grid display. Well, it says that right now it's at 20. If we add 10 to it, what would that be? So the answer for this first question is 30 millimeters. We see right here that we have two digits that we need to fill in. So we type in 30 for 30 and we move on. Next question. Which of the following options are available when launching a new project? Now on Inventor, this is something that I haven't covered with you, but when you want to launch a new project, you have to make sure that you're on the home screen. You can click right here to go to the home screen, or you can click up here at the very top, the quick access toolbar, and click on the home, and it takes you to the home screen. To create a project, it's just like opening up a brand new file, but you're going to click on projects. Now when it opens, you see this dialog box pop up, and we're going to create a new project. So we're going to click on New right here, and we have two options. What type of project are you creating? Is it a new single user project or a new Vault project? Well, that's what this question was originally asking. What are the options when launching a new project? Here on Inventor, it's new single user and new Vault project. So we choose single user and new Vault project. And we move on to the next question. Now for user interface and navigation, that was just two questions, but there are more that we might come across. But for this current test, there's only two. For Objective 2, Assembly Modeling, it's a little bit more advanced, especially if you've only been in my class for one semester or 1 year and you haven't learned how to create assemblies. So let's go ahead and look at what we have. Open Assembly Constraints. So let's go ahead and open Assembly Constraints. Okay. Oops. Cancel. Done. Make sure that you guys actually finish the previous question. Okay, let me try this again. Oh, there it is. Okay. So assembly constraints. We have two parts here. Let's go and see what that question was going to ask us. Constrain the two components. Make the relationship from the base of the bolt to the base of the nut. No offset. What is the distance of the remaining grip length or the bolt sticking out? So if we look at this picture, it wants us to put the bolt and the nut together and touch right here, and we have to measure the distance of the grip right here. So let's go to Inventor and figure that out. On Inventor, once we open up Assembly Constraints, we're going to go right here to the Constrain button. The Constrain dialog box, pretty simple, but we're going to be using what we see here. We see the center line of the bolt, so I'm going to click on that, and we see the center line of the bolt of the nut over here, and I'm going to click on that. Now they go together, and we're going to click Apply and then Cancel. I want to pull this back out, And then I want to make sure that I constrain this face of the bolt to this face of the nut and apply that. Now, all we have to do is measure from this face to that face, or the remaining grip length. So I'm going to right click, go to measure, and it should bring up a dialog box like something like that. I'm just going to click from here to here, and it gives us our measurement. I clicked from face to face, and our measurement is 0.787. When we go back to our exam, it's asking us for number dot number, or number point number. Okay, so 0.787, that's the answer, so that's what we would type in, 0.787. These number spaces, or these digit spaces, is exactly what you should be entering. Okay, let's move on. Open assembly creation. So let's go ahead and open that up, assembly creation. When you're working on these files, make sure that you don't save anything. Make sure that you just go ahead and move forward. Don't save. Just close the file, because you will need to use these files again. And if you save over the existing file, then you'll be out of luck in the rest of the exam if you have to open the files up again. Okay? So, open assembly creation. Create a part to fit the top surface of the block and cover the holes. The plate should fit the entire surface of the mating part and be 0.25 inches thick. Fill it one vertical edge to 0.25 inch radius. What is the surface area of the top of the new plate? Now, this is a lot of information. It's asking you to do a lot of things, but it's really not doing anything more than what you already know. One of the things that you can do inside of an assembly is create new parts. So I'm going to click right up here on create. It's going to ask us, what do you want to name it? Where do we want to save it? It doesn't matter. So just say OK. And I want to create my brand new part on this face right here. Okay, so everything goes gray. That doesn't mean anything as far as like the existing part. It just means that we're not working on it. And we're going to create a brand new sketch. I want to put my brand new sketch right on top. And I'm going to sketch as if normal. I'm going to go to project geometry and project what is already there. Finish my sketch, and I can go ahead and extrude what I just projected. It told me in the question to extrude it by 0.25 and to make sure that the holes were covered. So I'm going to select everything, type in 0.25 and say OK. And then it told me to fill it one vertical edge to 0.25 inch radius. Okay, so fill it one vertical edge. So just select a vertical edge and type in 0.25 on the radius and say OK. The question then asks us, what is the surface area of the top of the new plate? Finding surface area is not difficult. All we have to do is click on this face right here, right click, and go to measure. Right here is the surface area, 47.987. So if I go over here, 47.987, that fits. Okay, let's move on. So this one doesn't require us to open up anything. We're just going to go ahead and answer the question as best we can. What type of constraint would be used to constrain the nut to the bolt as shown in the image? So this requires us to think a little bit of what we would do in real life. If we had a bolt and we had a nut and we wanted to put the both of them together, what would we use? Okay, would we use mate? Mate just means like touch them together. Does that work? No, we want the bolt to go inside the nut. Angle, do we want them to be at an angle to each other? No, not really. Tangent, remember that tangent is a circle touching a line at one point. Symmetry, well, there's nothing really symmetric about turning the bolt and the nut into this. And last is insert. And that makes sense. We're going to insert the bolt into the nut to create this image. So I would click on insert, and that's the answer. Let's move on. So we don't have to open up anything for this one, but it does require us to think a little bit. So it says, assume you apply a mate flush constraint between face 1 and plane 2 in the image shown. So we're going to attach the blue face here to this yellow-orange surface here. Which of the excuse me, which of the following adjustments cannot be made to the block once the constraint is in place? Choose all that applies. So we're going to touch this to that. So then let me go ahead and get some visuals to help you see this. All right. So we have our plane and then we have our actual object. So we have our object like this and we're going to touch this to this. Transition basically means to slide it from left to right, front to back, up and down, and then rotation like this, rotation like this, and rotation like this. Okay? So when we look at this problem, it's going to ask us, can we transition along? So it says, which of the following adjustments cannot? So will we be able to transition along the y-axis? So the y-axis in this case is going up and down. Can we move, if we glue this surface to this here, will we be able to move up and down? Yes or no? Transition along the x-axis, left and right. Can we move left and right? Yes, we can. Transition along the z-axis. Can we move front and back? Yes. So the only thing that we can't do is once we stick this to this, we can't move it up and down. Like that object is stuck to the plane. Next, rotation about the y or about the x-axis. So the x-axis is rotating this way. Can we rotate it this way? No. Can we rotate around the z? No. Can we rotate about the y? Yes. So everything that we answered no to is the answer to this question. So transition along the y, rotation about the x, and rotation about the z are the correct answers. Next question. Which type of inventor file is used to show an exploded assembly view? Now, for those of you that have not created the train project, this is going to be a little bit hard to just think of. So if we go to New and we bring up the dialog box and we see our standard file types. We have part, we have assembly, we have drawing, and we have presentation. So in order to make an assembly, we need several different parts. In order to make a presentation, we need an assembly. So what an exploded view is if we took a stick of dynamite and we exploded or blew something up, and we have lines showing where those different parts connect. So the answer to this question is a presentation file. What type of inventor file is used to show an exploded assembly view? It's a presentation file or a .ipn. Objective 3, drawing. So on the drawing sheets, you guys know like how to lay out top, front, side, and dimensions. There are other things that you guys can do inside of drawing files. So let's go ahead and open this up. Open Project Center Lines. So let's find that. So Project Center Lines, DWG. Okay. Hopefully it'll open. Come on. There it goes. All right. So we have our file open. Finish the drawing by adding center lines and dimensions. What is the dimension in inches of the center line from the bottom edge of the plate? So basically from the bottom edge of this rectangle to the center line, what is that distance? So we go into Inventor, we zoom in, and we're going to add dimensions. Well, first a center line and then a dimension. So we're going to go to Annotate, and then we're going to add a center line. So we're going to click on center line, click on the circle, and then click on this circle, right click, create, and then click on dimension, click on the center line, and then the bottom edge. What is the distance? 3.50, and we go over here, and it's asking us for 2 digits, so 3.5 would be the correct answer. Next, open plate. Okay. Oops, no, open plate DWG. So make sure that you guys are making sure that you open up the correct file type. Okay, so we have this. Oops, it says create a detail view on the right side of the field, of the drawing field. So create something over here. By default, what is the view identifier for the first view created on the drawing? Okay, it's pretty easy. So it wants us to create a detail view. And we're going to create a detail view of this object. Creating a detail view is pretty simple. We're just going to click on Detail. It's going to ask us to select a view. And then right here, it's going to tell us the view identifier. So the view identifier here is the letter, or the capital letter A. We go back to our question. The answer is capital letter A. That is the view identifier. Okay. So some of these questions don't require you to do too much other than to click on some buttons and find the answer. Which option in the image below represents a section view of the original assembly? Okay, so here is our original assembly right here. It has several different parts, and we're going to be finding what a section view is. Is it option 1? We see that we have sliced an object open and that we have section lines, so it could be option 1. Option 2, we see an isometric of the actual part. And option 3, we are just looking at a projected view or standard right side view of this part. So the correct answer to this question is option number 1. I'm going to go ahead and end this video right here. If this video has been about 25 minutes in length, and that seems like a good stopping point for us right now. If you guys have any questions, go ahead and make sure that you ask me, but I will see you guys in the next video. All right, bye guys.